Good morning, this is Dr. Turner for Integrated Math 2. Today we are going to finish up Unit 6. 6.5 is looking at right triangle similarity. This is going to follow the same principles that we saw in 6.3 and 6.4, but specifically with right triangles, we end up with some unique situations. Specifically, when we draw an altitude, remember an altitude is a line going from an angle to the opposite side, making a right angle because it's perpendicular. When you draw the altitude of a right triangle, you end up with sort of a special case. So this is 6.5 right triangles. So if I were to draw a right triangle, and again, forgive me that this isn't drawn to scale, but let's say I have a triangle, looks something like this. Again, assuming this is a right triangle, I'm going to call this triangle ABC. If I draw the altitude, again, that's the line going from an angle to the opposite side forming a right angle, and let's call that point of intersection D. What I end up with is actually three similar right triangles inside this figure. Obviously you have the original triangle ABC, and that's going to be similar to, if you sort of broke this apart into smaller triangles, you have a total of three right triangles here that are similar. So triangle ABC is going to be similar to triangle CBD, and it's going to be similar to triangle ACD. So remember, when you're writing your similarity statements, you've got to sort of trace it along the same shape. So when I say ABC, I'm sketching the hypotenuse of the triangle first as I go around. So ABC, the hypotenuse, and then to the right angle. Similarly with CBD, I'm tracing the hypotenuse to the right angle, and triangle ACD, the hypotenuse to the right angle. So all three of those triangles are similar to each other. Rather than writing a congruency statement or ask to justify your response, because we could do a number of things here. We could do angle side angle, side angle side similarity, or side 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 similarity. Instead of doing that, most commonly in 6.5 or questions involving 6.5, what you'll be asked to do instead is to solve for a missing value. So let's say I give you the hypotenuse here of the larger triangle. Say it's 100. This segment here I'm going to say is 36. And I'm writing x here, so I want to know for what values of x would these two triangles be similar. Just like we did in 6.3 and 6.4, this is going to involve setting up a proportion and doing cross multiplication. So you have to make sure that your sides are lining up. So I'm looking at the big triangle here, and then I'm looking at the small triangle inside using those congruency statements. So for the larger triangle, I have 100, but I don't have any other side. For the smaller triangle, I have 36 with no other side. So because of that, what I'm going to do is I'm going to fill in the missing value, 100 minus 36, and that would give me 64. Looking up here at my similarity statement, ACD is similar to CBD. So these two triangles would have to be similar. So I can write a similarity statement, say 36, which would be the shorter side, over x, which would be the longer side for that triangle, has to be equal to the shorter side, x, over the longer side, 64. So this is a cross multiplication problem. I'll do x times x, and then I'm going to do 36 times 64. Spare us here the time here. That ends up being 2,304. And then to solve for the value, I'm going to take the square root. Which gives me 48. So the missing value here would be 48. I would expect to see the setup here if you're doing this problem. So not just tell me x equals 48, I would expect you to show me how you got that. If you're uncertain, you can always check it. Remember, these are supposed to be proportional, so I can plug in 48, 36 and 48, 48 and 64. And if I reduce these fractions, these both end up being 3/4. So yes, that is my correct answer. Okay. Let's look at another example, number 2. So I have another right triangle here, and the orientation will change depending on the problem, so you just need to make sure that you're setting it up correctly. Draw my altitude here, and let's say I'm given the bottom side as being x, short side as being 9, and the whole thing as being 25. Okay. So again, question is, for what values of x is this going to be proportional or similar? So I can fill in the missing value there, which is 16. Now here, on the larger triangle, I have 25 and a missing value. On the smaller triangle, I have 9 and a missing value. So those are the two triangles I'm going to use in this case. Again, making sure that my correct sides are lining up. So 25 is the hypotenuse. X is the short side of that large triangle. And then looking at the smaller triangle, x is the hypotenuse, and 9 is the smaller side. So I cross multiply, I get x squared equals 225. And then take the square root, I get x equals 15. Of course, anytime you do a square root, you're going to get two answers, but because we're talking about length, we're ignoring the negative value. So we're just putting the positive 15 here when we take the square root. And that's pretty much all there is to it. Let's do one more, number 3. Draw my altitude here, large triangle. Let's say this side is 7, this side is 9. I want to know what the missing side is. So same thing, 7 over x equals x over 9. Cross multiply, I get x squared equals 7 times 9, which is 63. And then I will take the square root. Now, if you end up with a value that's not a perfect square, 1 and 2, we ended up with a perfect square. If it's not, for my class, what I want you to do is simplify the radical if you can. The directions will typically specify if it wants you to either simplify the radical, or it'll tell you to approximate it to X number of decimal places. 63, as we just saw, is a product of 7 and 9. So I can break that up into square root of 9 times square root of 7. And square root of 9 is 3. So our answer as a simplified radical is 3 radical 7. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.